So dear students, we have discussed in the last class some problems on line integration. Okay, and we have seen the last two problems that for one problem the integral, that is integral f dot dr, actually we have solved for a particular function. We have solved that the line integration f dot dr we have solved in the last class two problem, and both the problem actually we have solved f dot dr, and we have seen that the f dot dr is same for different path for a particular function. Actually for the first problem I can show you the problem. Okay, this problem, and I have solved this problem. So for this problem, for this particular function f, we have seen that the work done for this different path, for path 1, path 2, path 3 and path 4, for different path we have seen the work done is different. That is line integration f dot dr is different. This is different for different path. Okay, but in the next problem we have seen, for this problem we have seen, and here we have construct the function f. From here we can construct f, and here f factor will be nothing but minus y I cap plus x j cap divided by root x square plus y square. Sorry, not root, it is only x square plus y square, x square plus y square. And if we take f dot dr, that will be minus y I cap plus x j cap divided by x square plus y square dot dx I cap plus dy j cap plus dy j cap. And if we solve this, if we take the dot product of this, we will get this integration, that is integration f dot dr will be this, that is x dy minus y dx divided by x square plus y square divided by x square. This means here the function, the f vector, the force f is this minus y I cap plus x j cap divided by x square plus y square divided by x square plus y square. But in the last problem, previous problem, f was this xy I cap minus y square j cap. So when we take this force, and if we solve f dot dr for this four path, we will see each and every time different result. What it means? It means that work done by this force along different path will be different. Okay, that is path dependent. Here the work done by this force is path dependent. We have solved in the last class, you can see path dependent. But if we solve for this force, we will see that we have seen actually in the last class that the work done is along this path is same as what is work done along this path, along the straight path, that is triangular shape path, and this is the semicircular path, but the work done by this force is same each and every time. So this force is path independent. Work done by this force actually path independent. Okay, and according to this phenomena, actually we have defined two kinds of force field. One is conservative and another is non-conservative. For which force the work done is path independent is actually called conservative force or conservative force field. Conservative force field. And when the work done is path dependent, then that is called non-conservative. Okay, and we have seen, and we will see in most problems, that work done by this force is actually this force F is path independent, and we will see that this force is sometimes gravitational force. We will see that for gravitational force always the work done is path independent. We will see electrostatic force also. For electrostatic force same thing will happen. But whenever there is a frictional force, or there is a viscous force, something like that, then the work done will be path dependent. Okay, So actually here we have seen two kinds of things. One is this f dot dr is path dependent. Maybe this is path dependent, and sometime we will see that this integral is path independent. The result of this integral is path independent. Okay, so here this closed integral f dot dr is nothing but work done. This is work done. If this f is force and this dr is small displacement along the path, then obviously this w is represented as the work done by this force f. Okay, so whenever we see this, that the work done is different path, like different path or different curve that we have seen in the last problem also, different path. If here is w1, here is w2, here is w3, w1, w2, w3, then we will see when there is a path, when the integral is path independent, that means this w1 is equal to w2 is equal to w3 for each and every path. Okay, but whenever there is a path dependent case, then this will be not equal. Okay, so this force is then called non-conservative force. I am repeating again, the concept is very important. Non-conservative force. And example, you can say frictional force. And here this force is actually conservative force. And the field associated with this force is called conservative fields actually. Okay, whenever there is a force, obviously there is a field. That's why we have sometimes we have called this a conservative field, so sometimes we say that this is conservative force, but the meaning is same. Okay, the conservative force. And the example of conservative force is here, you can say gravitational force and electrostatic force. The most important conservative force, one is gravitational force and another is electrostatic force. Okay, so this is how initially the basic definition of conservative force or conservative force field you can say. Okay, and I can give you a realistic situation also. Let me consider a realistic situation that you can understand very easily. Suppose we are in an inclined plane, suppose, and we want to lift an object from ground to the top of this inclined plane up to this point. For this we have two options. We can lift the object from this reference level along this path on air, okay, from this point to this point, and the height that we have to cover is h, suppose. And we have other option, we can drag the object through the inclined plane. But if there is no frictional force, if we assume that the surface is smooth, then if we drag this mass from this point to this point, then the only force that will act on this object is gravitational force, and that is mg. And if this angle is theta, we can easily calculate that the work done to lift the object from this point to this point will be w is equal to mgh, and that will be minus mgh, okay, because work is done against the force. Mg is downward direction and the object is moving around this direction. We can prove this thing easily. This is just a 10+2 level problem. That it will be mgh, and along this direction you can easily see that this is mg, and if this is h, so it will be w is equal to minus mgh. The force is mg and displacement is h, but force and displacement are in opposite direction, so this is minus mgh, and this will also be minus mgh along this direction. You can easily prove this. Let me take. Okay, so if this is m, so this will be mg, and mg will have two components. One is perpendicular to this and another around this direction. So this angle will also be theta. So this will be mg cos theta and this will be mg sin theta. So here mg sin theta will use around this direction. the component will be mg sin theta. So the object is pulled against this mg sin theta force. Okay, and if the length of this inclined plane, let me suppose that this is L, so work done is actually minus mg sin theta into L, because force is along this direction, mg sin theta, L is along this, so mg sin theta into L, so it will be just minus mg L into sin theta. Now if you put the value of sin theta will be what? Perpendicular, that is h, divided by hypotenuse, that is L. So h is equal to L sin theta. H is equal to L sin theta. So you can put here. So it will be minus mgh. So you can see, if you use this path or this path, same work is done for the object to reach this point. That means here actually that work done by the gravitational force mg is independent of path, and that's why gravitational force is a conservative force. But if you assume that there is a frictional force also, then you have to work done against this gravitational force as well as against the frictional force, that is the dissipative force. So the work done will be different along this direction, along this path, and the work done will be different along this path. So whenever there is a frictional kind of situation, frictional force or viscous force is arise within the system, then the work done will be path dependent. So that's why whenever there is a frictional force or the viscous force, that force will break the rule of path independence, and that's why these forces are called actually non-conservative force. Okay, but for conservative force you will have same thing, you will have same work done for each and every path. Okay, so now we can see that the work done is path independent, and it actually means that the f dot dr is path independent. So in general, work done is what? This is a very special kind of situation. Okay, but in general the work done is nothing but integration f dot dr, line integration f dot dr. Okay, and whenever there is this kind of situation, that this line integral f dot dr is independent of path, we will get a relation between f and w. Always there will be a relation between f and w, and the relation will be just f is equal to gradient of w. We will get this. Whenever this is independent of path, this integral, we have a relation between f and w, and that is f is equal to gradient of w, and obviously the curl of this function will always be 0 in this situation. The curl of this function will also be 0. We will prove this thing later on. Okay, when we will study about the Stokes theorem, the vector integration theorem, then we can prove from this that if this integration is path independent, then obviously the curl of this function is equal to 0, and f will always be gradient of this w. Okay, and here w, let me suppose that the w is a function of x, y, and z. W is the function of x, y, and z. Okay, so in this situation we will get that curl of f is equal to 0 and f is equal to gradient of w. So these are two properties you can say for conservative force. So if we have to check that f is conservative or not, instead of finding the independent of path, we can find curl of this function is 0 or not, or is the function f obeys this rule, f is equal to gradient of w. Okay, this can be proved. So I can prove this here I can prove this, that if curl of f is equal to 0, then f is equal to gradient w, and obviously vice versa, if f is equal to gradient of w, then obviously curl of f is equal to 0. So if we assume that f is equal to gradient of w, then obviously we can prove from here that curl of f is equal to 0. Or if you assume that curl of f is equal to 0, then obviously we can prove from here that f is equal to gradient of w. But this proof that when the integration f dot dr is independent of path, then obviously it will follow this relation, and whenever it will follow this relation, we will get this. So we will prove this thing later on. But now it is sufficient to say that if f is equal to gradient of w, and we know that gradient of w in Cartesian coordinate system when w is the function of x, y, z, this can be defined like this: del w del x I cap plus del w del y j cap plus del w del z k cap. This is the definition of just gradient. Okay, and you can say this is the x component. So fx is equal to, you can say fx is equal to the x component of f. Okay, so you can f is equal to this, because f is equal to gradient of phi and gradient of w, and gradient of w this, and this is nothing but fx I cap plus fy j cap plus fz k cap plus fz. So you can write that fx is equal to what? Del w del x, and fy is equal to del w del y, and fz is equal to del w del z. You can write. Okay, you can write. So now if you want to find out curl of f, then you can find that this curl of f is equal to 0. If you take this f is equal to gradient of w, and fx is this, fy is this, fz is this, then we can easily find out that curl of f is equal to 0. Okay, so let me find out how this curl of f is equal to 0. Okay, so curl of f, what is curl of f? That will be I cap, j cap, k cap, and del x, del y, and del z. Okay, and the component of f, you can say del w del x component, y component is del w del y, and z component is del w del z. Okay, so what is I cap? So I cap is, you can find out that del y of del w del z minus del z of del w del y. Similarly, minus j cap, you can find del x of del w del z, del x of del w del z minus del z of del w del x, okay, plus k cap into del x del y, del x this, and this is del x del w del y minus del y del w del x. So this will be curl of f. Now if you assume that this order of differentiation is same, that if you assume that, what this means is equal to del y of del w del z is equal to del 2w and del y del z. Similarly, del z of del w del y will be del 2w and del z del y. So now this order, if this order does not depend on, if the differentiation, second order differentiation of w, partial differentiation, second order partial differentiation of w, it does not depend on this order, then what will happen? These two will equal, so this term will be 0, this term will be 0, and this term will be 0. So curl of f will be 0. Obviously, curl of f will be 0. So in this situation, you can see, if you assume that f is equal to gradient of w, then we can assume that the x component of this, y component of this, and z component of this, and assuming this, we can prove that curl of f is equal to 0. So what I can conclude here is that if we have line integration f dot dr is independent of path, then we can find a scalar function w, which is a function of x, y, z, such that f is equal to gradient of phi, so gradient of w. Okay, and if f is equal to gradient of w, then we can prove that curl of f is equal to 0. So these all three are the properties of conservative force f. So if this independency path, if this result is hold good, then these two results will hold automatically. So if we find that, similarly if we find that curl of f is equal to 0, then also f will be gradient of w and f dot dr will be independent of path. So what we have to sometimes check that f is conservative or not, then this is very easy to derive that curl of f is 0 or not. So this is the best way to find that a given function, a given vector function f in terms of I, j, k cap, I cap, j cap, k cap in Cartesian coordinate system. Basically, if f is given in this form, then it is very easy to check that its curl of f is 0 or not, and we can conclude from here, if curl of f is 0, then f can be said as conservative force. Either if curl of f not equal to 0, then we can conclude that f is non-conservative force. Okay, and another important thing I have to say here, that what is f dot dr. If we want to find out f dot dr, then we can write that f is gradient of w. Say this will be gradient of w dot dr, and that will be, you can say, that is del w by del x I cap plus del w by del y j cap plus del w by del z k cap dot dr vector means dx I cap plus dy j cap plus dz k cap. Okay, so it will be nothing but del w del x dx plus del w del y dy plus del w del z dz, and this is nothing but the total differentiation, that is dw. So f dot dr is nothing but dw. So if we integrate this function f dot dr from initial point to final point, suppose a to b, which implies that integration dw, which is a to b, so it will be w at the point b minus w at the point a. Okay, so you can conclude that the integral, the line integral from initial point to final point, so if we conclude it like this, so we can find that integration a to b f dot dr is equal to wb minus w. So suppose this is a point a and this is the point b. So if the work is done from a particular path from a to b, then we can find this a to b. Now instead of this one path, if we take the closed path like this, so it is starting from a and it will end at a. So this point is not necessary now. So its starting point and the final point is same. So we can write it in this way: a to a f dot dr, and that will be wa minus wa. In another form, you can say this notation is not conventional, but instead of this we can use this as closed integration f dot dr. This is the work done along a closed path, and that will obviously 0 because wa minus wa is 0. So this is also one of the property of path independency or the conservative force. So integration a dot dr, integration f dot dr. If integration f dot dr path independent, that means its closed path integration is obviously 0. So this is also one of the fact that we can check from here, that f is conservative or not. If closed path integration of any function is 0, then we can easily say that f is conservative. But it is always, from here we can prove from here by using Stokes law. We will see later on that curl of f is equal to 0. Okay, and when curl of f is equal to 0, we can prove that f is equal to gradient of w. Okay, so now let me take a function. Okay, let me take a function. and let me check whether curl of f is 0 or not. Okay, curl of f is 0 or not. So here we have a function, okay, f is this. So that f is conservative. So first we have to find out this. Let me suppose find out if f is conservative or not. So what we have to do, we have to just check that curl of f is 0 or not. So let me find out curl of f. So this is I cap, j cap, k cap, del x, okay, del y, and del z, and the x component is 2xy minus z cube, y component is x square, and z component is minus 3x z square plus 1. Okay, so it will be just I cap. Now this, so del y of this 0, and del z of this is also 0, minus j cap, you can find del x of this, is minus 3z square, and del z of this, minus del z of this will be plus 3z square, plus k cap, this and this. So del x of this is 2x, minus del y of this is 2x. So each and every component is 0, you can see. So it will be 0 obviously. So curl of f is equal to 0. So that means this function f is conservative in nature. Okay, now let me find the corresponding scalar potential. So how can we find the scalar potential? So let me understand about potential now. Okay, what is potential actually? Potential actually means, okay, so what it actually means, potential. Okay, so potential is nothing but the work done, obviously the work done, but you can see we have seen that f is equal to gradient of w. Okay, we have seen that f is equal to gradient of w, If we find w, okay, then we can easily find out potential phi. Potential is sometimes represented by phi. And what is this? Let me take an example to understand this potential. Okay, so actually this is negative of w, because sometimes you can see, suppose here is an object of mass m, and work done, if we lift this object at a particular height h, then work done w is equal to minus mgz. And in this situation, if you calculate the change in potential, increase in potential, that will be phi, and that will be plus mgz. So w is always equal to minus phi. So if w is minus phi, then we can write that f is equal to minus gradient of phi. Okay, so this is how we can define potential also. Another way I can also define this, but here it is sufficient to say that f is equal to gradient. If you know that f is equal to gradient of w, then obviously f is equal to minus grad phi. I will explain it later on also. Okay, also I will explain it later. But now in this stage it is sufficient to know that phi is equal to minus w or w is equal to minus phi. Okay, so f is equal to minus gradient of phi. So if you want to find out potential, then it is necessary to find out w. Whenever you can find w, you can easily find out phi, because w is equal to minus phi. Okay, so how you can find out w or phi? So what you have to do, you have to just first find out, you have to just integrate the function, because you know we have just dw is equal to f dot dr. We have this dw is equal to f dot dr, and we can suppose this is given, f dot dr is given, and we have seen that suppose this dw is equal to f dot dr is given, and if we find by calculating that curl of f is equal to 0, then from here we can get a hint that obviously there is w corresponding to f, such that f is equal to gradient of w. So it will be obvious thing. Okay, So otherwise, if curl of f not equal to 0, if we can find by calculating that curl of f is equal to curl of f not equal to 0, then it is not necessary to try to find out f. Okay, because you cannot find w. If curl of f not equal to 0, then you cannot find w. So whenever you are asked to find out w or find out phi, what you have to do? You have to just first check that curl of f is 0 or not. If curl of f is equal to 0, then only you can try to find out f. Okay, now how you can find out f? You have to just integrate the function f. Integrate the function f. Okay, because you know here, if f is equal to gradient of w, then it's if you want to find the x component. So what is fx? So fx is just del w by del x. Okay, so del w is what? Fx dx. So how you can find fx dx? So how you can find out w? So w will be obviously integration fx dx. Okay, so in this way just you can find w, but there will be some integrating constant obviously. So for this integrating constant, to find out this integrating constant, what you have to do? To find out this integrating, you have to choose it will depend actually the chosen, how you can choose the initial point. Okay, initial point. So it will depend on the points. Okay, because this f dx is work done. So you have to just choose initial point to final point. Okay, so it will depend what will be this integration constant. It will depend on your choosing of origin. Okay, from where you are going to find out this fx dx or this integration. But in general, you can say, in general, this is one component. But in general, what you have to find out? You have to just find out integration f dot dr. You have to just find out integration f dot dr to find out w, because w is equal to integration f dot dr, you know. But for this, we have to take a path to find out w. This is also one way you can find out component wise. Okay, so fx dx, fy dy, fz dz, you can integrate this and you can find out the each and every component. Okay, x component, y component, z component. But we are not going to this way. This is more complicated. Okay, but 3 times you have to take the integration. But this is not. I am not actually suggesting you to do this process. But this process is very easy. What you have to do? If you want to find out w, you have to just go through this process. W is equal to f dot dr. And why I am suggesting you to go to this process? Because whenever you will find curl of f is equal to 0, then obviously you know that this f dot dr will be independent of path. Then what you can do? You can just choose arbitrary path, any arbitrary path you can choose to find out this w. Because once you know that curl of f is equal to 0, then you can find w easily by using this integration. But here the freedom of your is that whenever you will see that curl of f is equal to 0, you can choose any path, because this is independent of path. So you have to you can choose the path as your own choice. So your integration will be so simple. You can choose the path in such a way, so you can easily find out w. Okay, so whenever you are asked to find out phi, you have to find out w, and whenever you want to find out w, you have to check first curl of f is 0. So let me find out phi or w, the previous problem. Okay, so here in this problem, we have already seen that curl of f is equal to 0 for this case. We have already seen that curl of f for this function is 0. So we can easily find out f dot dr, integration f dot dr, by choosing any path. So let me find f dot dr, and we have to also choose the limit of this integration, from where we are going to start, and on that reference point you will get the integrating constant. Okay, so what is f dot dr? So here from this expression you can find this line integration f dot dr will be simply 2xy minus z cube dx plus x square dy minus 3xz square plus 1 dz. you will get this. Okay, and now let me take a path. Suppose my path is starting from origin, so it will be 0, 0, 0. Then I like to choose along x-axis x, 0, 0. Okay, then I like to choose x, y, 0. Then I like to choose x, y, z. So I am going from this point 0, 0, 0 to arbitrary point x, y, z through this path, to these two intermediate points. So what I have to do when I am calculating this integration, let me see. So first what I have to do, I have to take this for these 2 points. For these 2 points you can see x, y, x is varies from 0 to x is varies from 0 to x, but y and z are 0. Y is equal to 0 and z is equal to 0. What it means? dy is equal to 0 and dz will also be 0. That means this and this will obviously 0. And as y, z 0, so here is y, here is z, so this will also be 0. So the value of this integration for this path will be 0. And let me see for this path. So for this path we can see x is equal to constant and z is equal to 0. We have x is equal to constant, that means dx is equal to 0, and we have z is equal to 0, that means dz will also be 0. So how this integration, we can do this integration for this path. Dx is equal to 0 means this part will be 0, and z is equal to 0 means dz will this part 0. So only survival part will be this, so it will be x square dy. So integration x square dy, and x is constant here along this path, so it will be x square into integration dy, and y is varies here from 0 to y, so the integration will be x square y. Now let me see the last part. So here you can see x and y are constant. X is equal to constant, that means dx is equal to 0, and you can see y is equal to constant, that means dy is equal to 0, and z is varies from 0 to z. Okay, so dx will be 0, dy will be 0, that means this two term will be 0, and here x is constant. Okay, x is constant, y is also constant, and z is the only variable, so we will get minus integration 3x z square plus 1 into dz, and z varies from 0 to z, so it will be minus 3x into z square dz means z cube by 3 minus z, so it will be minus x z cube minus z, okay, so this will be, I think yes, it will be minus x z cube minus z. So the total line integration will be the sum of each and every part, so the total f dot dr we can find here, that f dot dr is nothing but x square y minus x z cube minus z. So this is w, because you know w is equal to f dot dr, so this is w. So we can find in this way w is directly, that is x square y minus x z cube minus z, okay. And whenever you are asked to find out phi, scalar potential, then phi will be minus w, and that will be minus x square y minus plus x z cube plus z. So this will be phi. Okay, so in this way you can find out w. Okay, so now one thing is left corresponding to this topic is that exact differential. Okay, so what exact differential is? So whenever you have f dot dr, okay, so you can see we have w is the function of xyz, and we know dw is equal to just del w del x into dx plus del w del y into dy plus del w del z into dz. Okay, so in this situation this w is called exact differential. This w is called exact differential, actually exact differential. exact differential. But we can see, we can tell it this W, this is actually total differentiation, but this is called exact differential only when you will get that this is nothing but f dot dr. This is what, this is just f dot dr, and when this f dot dr can be written in this way, only when f will follow this relation, f is equal to gradient of W. I have discussed previously that only when f will follow this relation, f is equal to gradient of W, then we will get f dot dr as this. So in this situation, this dw is called exact differential. That means a sufficient and necessary condition to be W exact differential, that curl of f is equal to 0. Obviously, we can conclude that if curl of f is equal to 0, then only we will get dw is this, like this. Okay, that is f dot dr. F dot dr is this. We will get f dot dr is this in this form. Only when f is equal to gradient of W, and f is equal to gradient of W only when curl of f is equal to 0. So we can say when curl of f is equal to 0, then the corresponding W, the corresponding dw, and here what is f is W is equal to integration f dot dr. In this case, if you take the dw, then dw is equal to integration f dot dr. This dw is known as exact differential. So whenever you are asked to find out a particular dw is exact differential or not, what you have to check? You have to just check f is conservative or not. Okay, and what is the another way of discussing this thing, or another way of representing of this thing? Let me tell you. Okay, so what this curl of f means actually? Curl of f is equal to 0 means what it actually means? Curl of f is equal to 0. So we have seen earlier that curl of f means, let me show you. Okay, so here curl of f I have discussed earlier, I think. Okay, so let me do it again. So what we actually mean by curl of f? Curl of f is equal to 0. This means actually, so let me find out curl of just what first. So what this means? Curl of f means I, j, k, del del x, del del y, del del z, and this is fx, fy, fz, and fx, fy, fz can be written as del w del x, del w del y, del w del z only when f is equal to gradient of W. Okay, only when f is equal to gradient of W. Okay, and that's why we can see that will be 0. Now to do this 0, we have assumed that the second order differentiation of this W, it does not depend on the order x and y, because we have seen that from here we have the I component as del del x of del w del y minus del del y of del del y del w into del x. Similarly, we can find out the j component and k component also. Similarly, for j component we have del del x of del w del z minus del del z of actually del w del x. Similarly, we have the k component as del del x of del w del y minus del del y of del w del x, and this will only be 0 if these are equal, this and this is equal, this and this is equal. And what this means? This means the differentiation of this function with respect to x is same as differentiation of this function with respect to y. And what this is, this del w del y is what? This is just the y component of f. This is actually fy. And this is the x component of f, that is fx. This is the z component of f, which is fz, and this is the x component of f, and so on. So what this actually means, this means del fy del x should be equal to del fx del y. Similarly, del fz del x should be equal to del fx del z, and obviously del fy del x is equal to del fx del y. So the differentiation of the component of f, x component, y component, and z component will be same. Okay, if you want to find out the differentiation with respect to x or with respect to y, so it will interchange. Okay, it will interchange. In thermodynamics, this relation is known as reciprocity relation. In thermodynamics, this relation is known as reciprocity. This relation is known as, I think, as reciprocity relation in thermodynamics. Okay, reciprocity relation. Okay, and in mechanics we can see that this is nothing but curl. This symbolized that curl of f is equal to 0. This symbolized that curl of f is equal to 0. Okay, so and this is also the case of exact differentiation. This is also the condition of exact differentiation. Sometimes to show the exact differentiation, dw is exact differentiation or not, sometimes we have seen this. Okay, we have to prove this. Okay, so dw is exact differentiation if and only if f is equal to gradient of w and curl of f is equal to 0. You can tell either this or this. And in other words, you can tell that dw is exact differential only when these relations hold good. So let me see if these relations holds good or not for the given function that we have discussed earlier. So let me take this function. Okay, this function. So this is the x component, this is the y component, and this is the z component. So to what we have fx is equal to just 2xy minus z square, fy is equal to x square, and fz is equal to, we have minus 3xz square plus 1. So if we take del fx del y, so what you will get? You will get just 2x. And if you want to find out del fy by del x, you will get 2x. And if you want to find out del fz del x, you will get minus 3z square. And if you want to find out, this is z cube, and if you want to find out del fz del z, if you want to find out del fz del x is this, and here if you find out del fx del z, okay, del fx del z, then you will get minus 3z square. So you can find that del fx del z is same as del fz del x. Similarly, del fx del y is same as del fy del x. Okay, so these relations hold good. That del fx del y is nothing but del fy del x. Similarly, del fx del z, you can see del fx del z is same as del fz del x. Similarly, this relation will also hold good, because del fy by del z is 0 here, and del fz del y is 0 also here. So this relation will also hold good, that del fy del z is equal to same as del fz del y. So these sets of relations will hold good if f is conservative. That means if curl of f is equal to 0. So you can see that here what is del w, dw. So here dw is nothing but 2xy minus z cube dx plus x square dx minus 3xz square plus 1 dx dz. So this is exact differential. You can see this is exact differential. Why? Because these relations hold good. Okay, so this is one way of finding out that dw is exact differential or not. If these relations hold good, then you can say dw is exact differential, and this relation will only hold good if curl of f is equal to 0, or if curl of f is equal to 0, this relation will hold good, and if this relation will hold good, we can see dw as exact differential. But if you slightly change the function, if you take plus sign here, then you will not get the component, the differential that I have written earlier will be same. So here in this case dw will be 2xy minus z cube dx plus x square dy plus 3xz square plus 1 dz. This is not exact differential. Why? Because you can see, if you find out this is fx and this is fz, you can find out you have del fx del z is equal to minus 3z square, but if you find out del fz del x, you will get 3z square. So this relation will not hold good. So this is not the exact differential, and obviously if you want to find out curl of f, you will get curl of f not equal to 0 here. Okay, so these are the consequences of each of vice versa thing. So if curl of f is equal to 0, then this differential will also be equal, but if this curl of f not equal to 0, then this will not be equal. Okay, three sets of equation you can say. Okay, one is xz, one is xy, and another is yz. These three sets of differentiation. Okay, if these three sets of this reciprocity theorem, you can say, if this reciprocity theorem between these variables will hold good, then you can say that dw is, or this function is differential, and that will only be happen if curl of f is equal to 0. Okay, so this is how we can define, or we can understand the conservative, non-conservative force, potential, and exact differential. Okay, and we will be repeating this thing again when we will study about the integration theorem, because this conservative force or this conservative field we cannot study in a particular position, because it will come again and again. Okay, it will come again and again, and whenever it will come, it will arise, I will discuss at that time. Okay, whatever we need, we will discuss for a particular time. Okay, so now for these topics in this position, this is sufficient to say about the conservative and non-conservative force field, about the scalar potential, about the exact differential, etc. Okay, so thank you.